So the Warburg effect is a mechanism by how cancer cells use only glucose for their energy. They can't use fats and they can't use oxygen. And unfortunately, Otto Warburg, who discovered this in the 20s, was German. And of course, no one liked Germany in the 20s, 30s and 40s. So even though he got a Nobel Peace Prize for it, his research was largely buried. But Thomas Seyfried, Professor Thomas Seyfried at Boston University in America, has carried on his work like this.
Let's look at this guy. Now, you know this guy if you've been following Carrie, because Dr. Seyfried, I mentioned earlier that he's a living legend. He took the work of Dr. Warburg and kind of took over and put it back in the public sphere. And he also believed that ketogenic diets and carnivore is a ketogenic diet and fasting were the keys to treating cancer because it's a metabolic disease. So here's an example of what happens with a normal source of energy, which is glucose, and it's called glycolysis. So when you're converting glucose to energy, we call it glycolysis. And as you can see from this example, if you don't have oxygen around in a normal cell, it's going to only have a path towards making pyruvate and then lactate, and you only get 2 ATP. So 2 sources of adenosine triphosphate, which is our source of energy. And of course, this is all happening in the place where we make energy, which is our mitochondria. So that's the first thing you need to know. The second thing you need to know is that sometimes you do have oxygen available, and that's called oxidative phosphorylation. And so you take the glucose and you can convert it from pyruvate to, in the mitochondria with the oxygen present, you can get 36 ATP. So this is a more efficient model that we tend to use in our body. So 1 glucose molecule turn into 36. But guess what happens in cancer? Cancer cells do a process called aerobic glycolysis. And you would think that when they take that glucose to pyruvate, they would also, in the presence of oxygen, want to get 36 ATP. But unfortunately, they don't. They, for some reason, just they block that pathway, and then they end up with lactate and only 2 ATP. But it's really important to understand that this is how they live and survive. And because of this mechanism, because of this process, they depend on could you imagine how much energy a cancer cell that's growing fast needs? So it's going to go crazy looking for glucose. So if you have a dietary pattern that's feeding cancer glucose, unlike carnivore, you're going to basically be feeding the cancer. So I wanted to put that in front of you so you'd understand what this Warburg effect is and why it's important to understand it. Now, here's a study published that in the Internal Journal of Cancer, and it said ketone supplementation decreases cell viability and prolongs survival in mice for metastatic cancer. I could list I could have put tons of studies in front of you with dealing with keto and cancer. Again, carnivore is a keto diet as well. I'm just showing you this just to kind of point out that a few things that's important to understand. So they're saying in this study, although ketone bodies are efficient energy substrates for healthy extrahepatic tissue, cancer cells cannot effectively use them for energy. So the message in that first paragraph, that first sentence, is that you cannot use ketones effectively as energy. And there's also this other part of cancer cells. Widespread mitochondrial pathology has been observed in most, if not all, tumors examined. So that leads to a decrease in the mitochondria number, the structure, and other things that happen in the mitochondria. So you have 2 things here. You have ketones are not a good source of fuel, which means that a low-carb keto or carnivore diet is probably not good for cancer. And you also have, it's good for cancer treatment, but not good for the cancer cells. And then the mitochondria is dysfunctional in cancer cells. And that's really important to understand. And it says, although
Really simple.